Let's now directly come to question number 3. You are given two subsets A and B of a given universal set U. Now you are asked to find the one which is not what? The true one. So in the first case, A minus B is equivalent to A intersection B prime. B, A subset of B by implies B prime subset of A prime. C, A subset of B implies A minus B is different from empty. And D, A is a proper subset of the power set of A. So let's now do this question together. Students, what you have to know here is you need to remember the relationship between sets, right? Operation on sets and relationship between sets. Now, as you see, A minus B, it says, what is A minus B? A minus B by definition is, or A relative difference B by definition is a set that contains what elements in A but not in B. This, in another way, means a set containing elements in A but not in B means a set containing in A as well as in B prime. Because if an element is not in B, obviously it will be an element of B prime. So if X is an element of A and X is an element of B prime, it's obvious that X will be an element of the intersection. So X is an element of the intersection. So we can say that A without B is the same as A intersection B prime. So what has been written here in A is true. Remember, we are identifying the false one. And when you go to B, students, and when you come to B, here in the case of B, we know that A subset of B is defined like this. Whatever X you may take, if X is an element of A, obviously X has to be where? In B, in order to say that A is subset of B. But dear students, this is a conditional statement. Consider this as P and consider this one as Q. So this is P implies Q. So remember, we can now take contrapositive of this saying. The contrapositive of P implies Q is negation of Q implies negation of P. And we knew that a conditional statement is equivalent to its contrapositive saying. So this saying, X an element of A implies X an element of B is the same as student. X are not an element of B implies X is not an element of A. Because as we take the negation of this one, we do have this. X is not an element of B, and the negation of X an element of A is going to be X not an element of A. So as you know, if X is not an element of B, it's obvious that X is an element of B prime. And again, if X is not an element of A, it's obvious that again X is an element of A prime. So if X is not, see within these two sets B and A, it's obvious that it will be within what? B prime and A prime. So for all X, if X is an element of B prime, then X is an element of A prime. And this can be understood as B prime subset of A prime by definition. So whatever you see two sets you might have, if A is a subset of B, then it's true that B prime is a subset of A prime too. So B is true. And when we directly go to C, students, in the case of C, we are having this. If A is not a subset of B, look, what do you mean by saying that? If A is not a subset of B, then obviously there is at least one element which is in A but not in B. So as you are looking for, you see the difference between A and B, that is the element existing in A but not in B, you do have at least one element. But here it says that the difference is empty. How dare it could be? It can't be. If A is not a subset of B, then obviously there exists at least one extra element here in A which is not in B. So the difference here cannot be empty. That is to say, identifying an element appearing in A but not in B can exist. At least one element can appear, so it can't be empty. Because of this, students, the saying of the C here is again true. But when we come to D, students, here A is an element of the power set of A. This is true. Whatever set you might have, the power set of a set is a set containing all possible subsets of the set. So all these possible subsets are now considered as element for the power set. But what has been written here in D is a proper subset. So this is not true because A by itself is an element of the power set of A, not a proper subset as well as the subset of this one, because A is an element now. So the right one is this one, but what has been written there is the proper subset. So the one which is not right is D. So the answer is going to be D. I hope everything is good for you. Now let's directly go to these two questions, question number 4 and question number 5. So in question number 4, you are asked to find the prime factorization of the least common multiple of 180 and 1176. Very simple, students. What we need to do is we have to write the prime factorization of these two numbers first. So the question number 4 goes like this. You have to now find the prime factorization of 180 and 1176 as follows. Clearly, as you are dividing 180 by 2, you do have 90. And when you divide again by 2, you do have 45. And by 3, 15. Again by 3, 5. And by 5, 1. So 180 can be written as a prime, in terms of prime factorization, as 2 square times 3 square times 5. Do the same for 1176. You simply divide this number by 2. And you do this 3 times, and then you divide by 3, because you will obtain a number that can be divisible by 3. And then finally 49 is going to come, and we knew 49 is 7 squared. So students, as you see, these two now are written being prime factorized, because 180 is written as a prime numbers, as a product of prime numbers 2, 3, 5. The same is true in the case of 1176. It's written as a multiple of 2, 3, and 7. Now, if you are interested to find the least common multiple of this, what you need to do is, first, you have to identify the common, prime numbers used here. So as can be shown here, you see, here we do have 2, and again here we have 2. So you have to select the one with the higher exponent, or with the larger exponent. So 2 cube is going to be selected. You do this when you are looking for the least common multiple. But in the case of greatest common factor, GCF, you have to select the base with, a smaller exponent. Come to next. Here you are having 3 against 3. So what do you think is having a larger exponent? 3 square, right? So 3 square is going to be taken. Imagine at the beginning you are having 2 cube, then 3 square follows. Now students, you don't have any common prime numbers anymore. So what you need to do is, had you been looking for GCF, you could have stopped here. But in the case of least common multiple, you have to include those non-common numbers. So we are having here 5, so 5 is taken, and then 7 square directly taken. So you are going to have the least common multiple of the two numbers as you see. Look, it is directly taken as you see. So basically this is available where students in A. Look, the choices. It's available in A. So proceeding to the next one, we have question number 5. So you have been told that x and y are real numbers, and z is 6 plus x plus yi, and w is y minus 2x minus I. Look, these two are complex numbers. And again, you have been told that 2z minus w is I. So having all this into account, you are asked to determine the values of x and y. Very simple, students. What you need to do is the following. So for question number 5, the solution runs like this. You have been told that 2z minus w is I. So first, you need to know what z is. Z is 6 plus into x plus yi. So take 2 directly as it is, and then multiply by 6. 2 times 6 makes 12, as it's written here. And then these two multiple 6 plus y again, so it will be 2x plus 2y. Remember, student, I just multiplied z by 2. Multiple this z by 2. Then 12 plus 2x plus 2y, I can come. And then it says minus w. W is here, so you have to consider this as a single entity. So when you take minus w, this negative is going to multiply each of these terms. So this will be minus is taken directly. Then I just took w directly from this one and wrote it here, as you see. Then this has to be equal with I, because you have been told that this is equivalent to I. So now what you need to do is you have to write this in terms of a plus bi form. So real parts must be operated together and imaginary parts must be operated together. Log students, here comes this. How will this obtain? Let me show you. This is 12. 12 comes directly, as you see, minus y follows because this is free from I. Not only this, minus minus turns plus, so 2x follows. So this expression is free from I. And then what comes next is, you see this one, those expression with i's, 2x plus 2y, 2y minus minus makes plus 1, so you are having this. Now students, you are equating, you see, two complex numbers. So the real parts must agree and the imaginary parts must agree too. So the imaginary number for this one is number 1, so this 2x plus 2y plus 1 must be 1. And the real part for the right side is 0, so this 12 minus y plus 2x must be 0. So equating these two, one can obtain this. 12 minus y plus 2x means students y minus 2x equals 12, and for the right one, 2x plus 2y plus 1 must be 1, and from that 1 is moved to the right, so 2x plus 2y 0 means y plus x 0. So students directly subtract downward, so 12 minus 0 makes 12, y can cancel with y, and then minus 2x with my x makes minus 3x, and from this x is minus 4 and y is also 4, because once you obtain x value you can substitute in one of these two systems of equations and then you can obtain y to be 4. So is there a choice having x minus 4 and y 4, students? Yes, look there, it is in B, so the answer for this is B. I hope you have understood the way I am doing this question.